You should be familiar with the quadratic equation x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And we use this to solve quadratic equations. Now the discriminant is this part here that's underneath the square root. And you should be familiar with the discriminant. This bit actually tells us how many solutions there are to a quadratic equation. So the discriminant tells us how many roots a quadratic equation has. How many roots is the same as how many solutions a quadratic has. So we're solving a quadratic is equal to 0. We're finding out when y equals 0, which is the x-axis. So it's how many times a quadratic touches the x-axis. So in this first quadratic, quadratic A, it touches the x-axis twice. We have two solutions. And this is when the discriminant is greater than 0. So b squared minus 4ac is greater than 0. And here we have two real roots. And another way of saying this is that the quadratic has distinct or different roots. The second case is when we have the quadratic just touching the x-axis at one point. And we say here that it has one real root, or another way of saying this is that it has equal roots. And this occurs when the discriminant b squared minus 4ac is equal to 0. The final case is when the quadratic doesn't have any roots. So here's an example of a quadratic with no roots. The equation ax squared plus bx plus c equals 0 doesn't have any solutions. And this is when the discriminant b squared minus 4ac is less than 0. And we say the quadratic has no real roots. So let's have a look at a sample problem here. Let's identify our coefficients. Of x squared, a is equal to 1. Our coefficient of x, b is equal to 2k. And our constant here, we've got a constant of k plus 2. Now to find out when this equation has two distinct roots, we need to solve the inequality b squared minus 4ac is greater than 0. So putting in our values of b, a and c, we've got 2k squared minus 4 times 1 times k plus 2 is greater than 0. So simplifying this, we've got 4k squared minus 4k minus 8 is greater than 0. And we can see we've got a common factor of 4 there. So let's divide by 4, giving us k squared minus k minus 2 is greater than 0. So when we factorize this, we get k minus 2 times k plus 1 is greater than 0. And of course, with any quadratic inequality, we now need to sketch the graph of this function. So we need to sketch a graph of y equals k minus 2, k plus 1. So again, this is a different quadratic that we're sketching here to our original equation here. Okay, so our critical values are 2 and minus 1. And we know it's a positive shaped quadratic. And now we're looking at where this is greater than 0. So when is y, our y coordinates, greater than 0? So positive y coordinates here, so we can sketch that region, and we've got positive y coordinates here. So now we can solve this. We can say k is going to be less than negative 1, or k is going to be greater than 2. So again, we've got two regions. We're going to have to write this as two equalities.